The question says, how many liters of 0.115 molar sulfuric acid are needed to neutralize, react completely with, 50 milliliters of 0.5 molar NaOH solution? So in this homework, we've only given you one example of this, but I strongly recommend that you do many examples of this because this is quite challenging, and in my experience, students need practice with this to get it. So we're doing a titration here. So we're given that we have 0.115 molar sulfuric acid H2SO4. And we're trying to neutralize that, or we're trying to use a certain amount of this to completely neutralize exactly 50 milliliters of 0.500 molar NaOH. So we know the concentration of this. We know that we used 50 milliliters of 0.5 molar NaOH. And this is basically what we're doing. In a titration reaction, we would do this with an indicator so that when the moles of this and the moles of this are the same, the color changes, so we know the moles are equal. So this is basically a titration question. These can be quite challenging, as I mentioned before. So in order to do this, what we need to do is we need to figure out what we're starting with. Well, if we're starting with a certain amount and a certain volume of NaOH, what we want to do is we want to convert from liters of NaOH, not milliliters, to moles of NaOH. So if you remember in the previous questions, it was always grams to moles to moles to grams. In a solution chemistry question, or in a titration question like this, it's actually liters to moles. Once we have moles of NaOH, we have a balanced chemical equation, so we can convert that to moles of H2SO4. Then finally, we can convert from moles of H2SO4 to liters of this H2SO4 solution. So in this case, we have liters to moles to moles to liters. If you have volumes and concentrations, you can do this. Versus masses, all you need is a molar mass, and the molar mass is you can find on the periodic table. So if you have a mass, you can convert it to grams. For solutions, you need both the volume and the concentration. So that's basically that. Sometimes the volume is unknown, like in this case. So how are we going to do this? Well, first of all, we need to remember that we always have to start with liters, not milliliters. So we want to take that 50 milliliters and divide it by 1,000, which is 0.0500 liters of this NaOH solution. We now want to convert from liters to moles using the molarity. What this 0.500 molar means is that 0.005 or 0.500 moles of NaOH are equal to or are in 1 liter of this NaOH solution. So there's 0.5 moles in a liter. In this case, we want to find moles and get rid of liters. So we want to put the 1 liter of NaOH on the bottom and the 0.500 moles of NaOH on the top. So molarity is moles per 1 liter. So it's 0.5 moles equals 1 liter. Sometimes you use it this way. In a second, we're going to use it flipped upside down. Now we want to convert from moles of NaOH to moles of H2SO4. Just like in previous question, from moles of one thing to moles of another, always using a balanced chemical equation. In this case, we want NaOH on the bottom because we have moles of NaOH. So we're going to put the 2 moles of NaOH on the bottom and the 1 mole of H2SO4 on the top. So 2 moles of NaOH, 1 mole of H2SO4. We now want to convert it to liters of H2SO4. Well, we know that this is the concentration of the H2SO4. Molarity written as an equality is 0.115 moles of H2SO4 equals 1 liter of this H2SO4 solution. Notice that I'm labeling the solutions because there's more than one in this question. So we have this equality. Well, in this case, we want moles to cancel, so we're going to put the molarity number of moles, 0.115 moles, which again came from this concentration, which was given in the question, and we're going to put the 1 liter of H2SO4 on the top, because molarity means moles per 1 liter. or this many moles, equals 1 liter of the solution. Now that we've got this all set up, which is the hard part, now we have to do the math. So just multiply by the top, divide by the bottom, repeat to the end, and we find that it's 0.109 liters of this H2SO4 solution that can be completely neutralized by this 50 milliliters of this half molar solution. So that's basically how that works.